Alright, so today let's do another small Arduino project, and this one will be some kind of a Pong game, although it turned out to be more of a breakout. So yeah, I found a way to make the LEDs be a bit in a better position. I just put longer cables. I just now use the multiple cables to make them longer. I mean, something like this. So yeah, they should stay now in a nicer position. So the setup should be almost the same as the one in the Tetris project. So I'll just go to the Tetris one, and I mean it's gonna be similar, although let's try that this time to use interrupts for the input. So instead of using the, I guess, 8 and 9 pins on the Arduino, let's use the int 0 and int 1. So for that I have to check uh, the documentation. I guess it was this one, and yeah, I guess here should have been some place with int 0 and int 1, somewhere on port D. I don't see it in this thing. Let's see. Okay, it's on the second page maybe. So yeah, so it's int 0 and int 1, basically on what, port 2 and 3 from the Arduino. So let's use those two as the input, and yeah, basically I'm gonna use again some cables as last time to connect the Arduino to the breadboard first. And I mean I haven't prepared them, so let's see. I'm gonna take some random ones. Okay, blue. Okay, I mean I remember I used blue for ground and like green for the VCC, so let's do that again. Why not? Okay, we'll have these two for that, and I guess we need two cables for the buttons and three cables like this for the data in, data up, like chip select and the clock for the LED. I mean, we need more stuff like connecting the grounds and plus on the breadboard. So yeah, let's see. I mean, I think we can use this side probably. Although yeah, let's use the far side. Maybe it will look better from this side. Maybe we'll have like more space or something. So yeah, I'll take the Arduino, put in the 5 volts, the and the ground, that. Okay, whatever. And then we can put them in the same place. So now both sides will have like power on the breadboard. Next thing would be connect all these cables from the things. Okay, so let's see. We have this gray one is for plus, so let's yeah, I mean, let's think about it. Maybe there's a better placement. But I cannot see it right now. So yeah, unless we do something like put a breadboard like this and the Arduino down here or something. But this might be, I mean, let's try to do it like this. So now we can put, okay, let's see. Let's not mess that up. So we have, as I said, gray is for plus and black is for ground. So we connect them. And now, I mean, all of these are stick together. So let's see. In the schematic, I did all of them in like the same place almost. So let's do the same thing. So we're gonna have blue is for data in. I mean, doesn't matter where we put them, so can be pretty much anywhere. So let's just put all of them next to each other. Something like this. So this thing still doesn't change, I guess. Yeah, I mean, yeah, it looks okay on I think. So then if I had purple keywords, but I don't, so let's just imagine that no, white one goes to white because I have a white one. Yeah, hopefully the buttons will look alright because I'll have to put them like somewhere here. So let's move all the stuff, like all of these, like on the further side because we don't really care about them that much. It's just connecting. Okay. So this one still goes to like no 10, 11, 12. Let's say. So this one goes to 12. We'll change it a bit so it's the other way around. Then let's see, I mean I have a blue cable, so yeah, and I have multiple blue cables, so at least blue will be also blue. Okay, and yeah, thanks for telling me that I put white too far. I mean, but it's too short. Never throw it away. So let's do orange for purple. Why not? It's a pretty close color if you're colorblind. So I guess our colorblind friends won't be now bothered by the mismatch. And I actually found a better blue cable. So this should, well, I mean, yeah, I didn't want to say anything, but okay, let's put it inside. Yeah, I was like, what the hell? I have two blue cables. So this one should come right here in the, is it 10th pin? Okay, so I mean now it's all right. So extra cable. Don't need it. Well, I mean, we need it for the buttons. So yeah, let me take the buttons and okay, as I said, these buttons will go on pins 2 and 3 because they want to use interrupts in 0 and int 1. I mean, we can use any pin as interrupt, but I think I understood a bit how int 0 and int 1 works, so let's give them a shot. So D3 and let me take some longer ones. Okay, so let's put the buttons because it's gonna make more sense then. So come out, you Ashen. Alright, so we have first button, and I mean, yeah, great. And the second one, so yeah. Okay, so we have them, and we need to do the same thing as before. Connect one of the. Why is this so long? Anyway, we connect one of the legs to ground, something like this. One of the legs to ground, and the other leg should be connected to. Well, I meant connect one of the legs to high and one of the legs to ground. And yeah, using a really high resistor, like a 10k ohm resistor for the connection with the ground. Alright, so we have that. And now we can connect the wires. Okay, so I mean, let's see, put this one here, and I mean, let's go just over it. So it's gonna be on the third pin, and the last wire is gonna come on the second one. So yeah, something like this, right? And I mean, if we connect the cable now, we should still see the Tetris game, I guess. So yeah, let's see if everything works. So it should go and do the Tetris game, yeah, because it's programmed on that. So yeah, I mean, now what? So let's see the buttons if they blow up. Okay, perfect. So the buttons don't work right now. Yeah, it's a bit annoying that this cable hangs and pulls the Arduino with it. So yeah, doesn't really matter. So let's see. How about we first try to make interrupts work on the Tetris game. Then we'll do an intermission because I already did some code in Raylib for the Breakout game. And yeah, then we do Breakout. So first, let's go in the Tetris bits. And let's see. So for @mega, we are gonna have to copy paste some of the stuff from here. so it's better to remind ourselves what we had. So I also thought about this thing, and I saw that, well, it doesn't matter right now, but you also have to set the port to 0 for this input setup to work, because you want the like to set some stuff. I was looking in the docs, and there was a table somewhere around I don't know, it was about IO ports, and there was a table, I think this one, yeah. So if you set the data direction to 0 and it's an input, you also have to set the port to 0 or 1 depending on how you want to use it. And I think we were in the first case. We had a pull down resistor, so probably the first case. Anyway, let me just go back to this one. So we are gonna use this stuff from here. So basically, how the int0 and int1 works, we have two registers that we have to set and use. It's the external interrupt control register and external interrupt mask register. And yeah, this one is pretty simple. We have 2 bits here, and we set both of them because we want to use both int0 and int1. So that's easy. And how about this AIC array? So this one, you set these 4 bits, and each pair controls something. So for example, the first 2 control on which kind of change you want the interrupt to be called. So we, for example, let's say we want the rising edge. So when you click the button, so if you clicked on the button, it will connect to ground. It will connect the ground to VCC. So that means that it's gonna, have a rising pulse on it, right, on the pin. So let's say we're gonna do 1 1. So it's gonna be all ones. Pretty simple, I guess. So let's have something. So these things we can delete, but yeah, sure, we don't need them anymore. So we are gonna do I'm not sure why I don't see it as okay, so I see it. It's at memory 69. It's a coincidence, I haven't planned it. So we have to set everything to 1 basically. So let's say it's gonna be equal to BVIC00 or IC01. Okay, so we set everything to 1, as I said. And then we set a mask to everything. So now this should, okay, let me just move this one higher. So this should enable input. So I have to call to say. And I think to be able to use SEI, we have to say here interrupt. So now we have some function here. Okay, perfect. So I think probably that should be enough to enable interrupts. So we can no longer do this thing. We are gonna have input as a global variable. And here we are gonna say input equals 0 or something. Or I guess even just after this thing we can set, it's like our CLI version. If you remember, in the CLI version we had input as a global, I know, and here if you get a, you make move left, move right, and then you set input to 0, and we had input come from another thread. So that's how I did it there. So now let's see. So to be able to use the interrupts, okay, I said input equals 0, but it should be a volatile int. So volatile is just so that the compiler doesn't remove it, because it's still used. I don't know why the compiler would remove it, but anyway. So let's have the interrupts. So we have to say something like ISR, and then pretty much this is everything, right? So int 0 vect. I think this is like the interrupt for I have no idea why you have to write that. For this thing, so when we get an interrupt on, let's say, int 0, we make input to -1, and if we get an interrupt on the second pin or on int 0, we make input equal to 1, something like that, I think. Yeah, I mean, let's try to see if make a mega build, make at mega copy. So let's see. Okay, I mean, sometimes it looks like it works. But not always. Like, and if I press the button, sometimes it keeps going to the, to the direction. Yeah, but most of the times it looks like it's working. I mean, maybe it's because I'm in a weird position and it looks, but yeah, it seems like it works, I guess. So the input now is a bit better than it was before. Like, even if we spam stuff. Okay, anyway, I mean, yeah, it looks like it's a bit decent. Okay, anyway, so then this is the way to actually do input in a better way. So now we are gonna copy paste this stuff. So let's go back to Pong Arduino, and yeah, now it will be like a, I guess, an intermission of me doing the GUI stuff, and I guess afterwards I'll just copy paste what code I made, and yeah, we'll move it to, okay, yeah, well, now it's gonna be the intermission, so let's go there, and let me just remember how I actually did. Okay, so now let's implement the code, and yeah, this is the past me basically. I just wanted to get the Raylib version out of the way, because yeah, let's do the code. So my idea is to have a folder here. Let's say for the GUI version. Let's call it GUI. And yeah, basically let's go inside of it and have a cmake list.txt. And yeah, I did this before with the cmake, so I'm just gonna copy. This is for having Raylib basically, and I do this thing from the docs if I remember correctly. Yeah, so I don't really remember, but yeah. So then we're gonna have the main file. It's gonna be just the simple main.c. Okay, let me see here. So this is for the include directories. I don't think we're gonna need that. Okay. And we are gonna link just with Raylib. So let me just create a main.c file, which is gonna have include stdio and the hello world print. Okay, so let's go into GUI, make directory build, cd into build, and we can cmake like that. So this should download the Raylib into dependencies and also build it. So yeah, like this is more so that we can have, oh, what? I have to go back and now run cmake build. This is more like just to have a view on how it came to look like right on the Arduino board. So we have the executable, and yeah, it actually compiles. Okay, so let's also do cmake, and this will create the compile command inside of the build, and that's just so Neovim can pick up the. Okay, let's move into this one, and let's just implement the game, right? And then I'll probably take some of it and move it to Arduino, and that's pretty much the idea. So let's go into the Raylib project and just copy paste the hello world basically. So let's see what this thing will do. So we build and then we can run main. So yeah, perfect. Okay, so I think how I'm gonna do it, so hopefully that's how I did it in the building the board phase. It's gonna be height, it's gonna be, let's say, 800, or maybe something like 1600, and width is gonna be 800, right? Like this is 16 rows and 8 columns, right? But we can also make it 800 by 400 just so it fits on the screen. Okay, so here we create a width and the height, and let's say Pong game or whatever, and let's see the screen again. So it's gonna be like vertical, right? And it's gonna be twice as tall. So yeah, you are gonna have to see how that is gonna look like. Let's have a define for paddle width, and maybe it's gonna be 100. And in terms of Arduino board, how much that means? So 400 is 8 rows, and I did it like half, right? So I have to divide by 2 and remove, wait, what am I saying? I have to multiply by 2 and divide and remove the zeros. So it's gonna be two LEDs basically. That's kind of small. It's kind of small. So maybe I can do it 150. That would mean 3 LEDs, and that's a bit better. It will allow us to say something like, if it's on the left side, it will bounce off in the left direction. If it's in the middle, it will go straight up. And if it's on the right one, it will go to the right and up. Or I mean, yeah, something like that. So we have the pedal width. Okay, let's say define. So that's that. So I'm not sure if I want to make the GUI look the same as the Arduino or have it play out smoothly, right? Like that's what I'm not sure about. But I mean, we're gonna see. We're gonna see. So say define bottom offset is gonna be something like 50. So some distance from the bottom. Then let's say the ball will spawn on top of the pedal and move up, something like that. So now let's see. So we're gonna have this thing. We can take the direction is gonna be 0. Now I was thinking if we press left we make the direction, or like we actually subtract direction -1, and here we add 1, right? So it cancels out if you press both of them. Okay, we might need a structure, or like I mean the pedal is gonna be just the X, so int pedal X is gonna be 0. Let's make everything global because this is just like a scratch pad, let's say, right? So we're gonna need a vector vec2 for the ball position. Somehow I guess I'm gonna try to just do that thing. So let's see, define cell size is gonna be 50 because we are doing half of 100. So this should be 16 times cell size, and this should be 8 times cell size. This is gonna be 3 times cell size. Okay. This doesn't really matter. Could be 0 or something. Yeah, whatever. Let's say it's gonna be 0. So we have the pedal X, and we can keep the X and the Y for the ball. But it might be easier to have floats, right? And then approximate them to numbers. So let's say we're gonna have a float. Yeah, that's not really right, because I was maybe thinking if you press once on the left and on the right, it moves it by one cell, right? So that's also an option. And the ball should be similar, but yeah, the ball should have also speed and stuff. So let's say struct ball is gonna be something like like this. But yeah, I mean, let's do vector to position, vector to speed, and I guess we can declare the ball as global. So struct ball will be 0, float paddle position is also going to be 0, and yeah, I guess that's everything for now in that place. This gives us the direction. I guess we can reset the direction to 0, right? And maybe also have it global, just to make stuff easy. Although that's not important. So let's do a function for drawing now, because let's have a draw. And yeah, like everything is gonna be squares. Okay, so clear background, sure, fair enough. We're gonna do black, although black, yeah, it's 0, 0, perfect. So let's see what this guy tries to do. So it's gonna be draw rectangle. I have no idea what this thing is though. So let's do draw rectangle. I mean, let's just remove stuff. Basically the rectangle, oh yeah, that's what I wanted to do. So let's try to get the position of the pedal in our grid basically. So we have to I guess it's easier to just have the width and the height like 16 and 8, and that's it, and maybe the pedal width to be 3, and then to scale it up to cell size or something like that. Right, so maybe let's have define game height is gonna be 16, define game width, define pedal width is gonna be 3, pedal height is gonna be 1, so something like that. So we don't need that. We have all these numbers, and then this is just for making stuff easy in our game there. So let's say something like this. Oh, this is also part of the game. So yeah, something like that. And I mean, can still keep, although not sure, maybe for this one, let's say int x, int y, and speed could also be an int. Although speed can be float, why not? Let's say maybe something like this, right? So the ball we have a ball structure like that. It's gonna be pedal x, which could be an int. Let's not do direction like that. So here we need to draw. So draw rectangle is basically position X, position Y, and we give it the width and the height. So it's gonna be pedal width times cell size, pedal height times cell size. I'm not sure what it try to do there. So this should draw the pedal, and let's make it red to be similar to what we are gonna see. So this just draws the thing. So let's have int direction, could be like a simple variable. So next up, let's say we also need an update function, obviously. We also need like an init for the ball. Yeah, but I mean, whatever. We could also use an init for the pedal X. So yeah, let's see. Although I'm a bit wrong here, because here we should use X. So int pedal position is gonna be pedal X times cell size. This is gonna be pedal position. Okay, we also need an update. So let's have here an update with the input of direction, and here let's have a draw. So then the update can come here, and we change pedal X with that. So now if we rerun this entire thing, didn't work. Interesting. And I guess that's because here we have to do pedal height times cell size to make it visible on the screen. So this should, I guess, is there like maybe a set target FPS, something like that? Yeah, it's a bit too fast, so we might need to think about how we do this thing. Like, I want to have more like a key pressed. Is key pressed, maybe? Like, I want to, even though I keep holding, I want to move only one square, right? So something like this. Something really lame, pretty much. Okay, so we have the update. Now the update. Let's have another structure, maybe. Let's call it world. And this will also have int pedal X. Okay, so even though we're gonna have world like that, this should also take a pointer to this type define world. So let's have a pointer to world W. Or is it? Yeah, I mean, I was like, oh, is this Rust? Seems like it's not. So here it should be W pedal And I'm gonna do it global just because should be easier. And also when we're gonna do it in Arduino, it needs to be global. Like from last time, that's what I realized. So we can do something like this, right? And we don't care about the part that's below here, basically. Like we are gonna reuse only this part in some sense. So we update the pedal. Okay. We also have to update the position of the ball, right? But first, let's see. Is this still working? Looks like it is. Let's have a function void world init, and it's gonna get something like that. And I would like to say that the position of the panel is gonna be 3, like somewhere in the middle, and that could be game width divided by 2, actually. Yeah, something like that. Something like that. So that's gonna be the pedal X. Oh, I mean that's the center. So for pedal position it should actually be plus pedal width, or is it like minus? Because pedal X refers to the, I mean we can keep it to be, yeah sure, the top left corner I guess, or I mean the left side. So let's do here world init. So now it should be I guess like more in the center. So that's good. And we might need to randomly initialize this thing or this thing. We can also use just something like value, but I would say this should be game width divided by 2. Oh, I meant the position. The position could be something like that. Game width divided by 2, and this should be, it should be starting from the pedal actually. So it should be on the y-axis, yeah, I mean let's say it's gonna be something like this, maybe. Well, I meant game height minus pedal height, find ball size, and here it should also be minus ball size, right? And here it should be game width minus ball size divided by 2. So it's gonna be in the center. So now let's draw a rectangle for the ball. I wasn't paying attention on what color it will have, so it's gonna be white, and then it's gonna be on top of the pedal at first. That's good. So here position 4 basically. So let's check again. So it's Yeah, it's pretty much on the center, so it's 3, 4, yeah. I mean, we have 8 cells, so it's a bit, if we make 9, it's gonna look a bit better, I guess. I forgot to rebuild. No, I didn't. What? That's strange. So if I do 11, yeah, for some reason I think I hard coded something again. Oh, yeah, this thing. It should be game height and game width. So now it should be dead centered. Yeah, if it's 9, but you know we have only 8 LEDs, so let's keep it 8. Okay, perfect. So let's continue. We have the ball there, and now we have to run the update. So let's see. Like it would maybe make sense the speed to also be an int and always be 1 or 0, like -1, 1 or 0, right? I think that's what it makes sense. Let's say on y it's gonna be -1 to go up, and I'm not sure about that one, so let's just say something like increase the positions just to see it happening. It shoots up. Okay, perfect. So let's have int new x is gonna be x plus speed on the x-axis. If we go out of bounds, we yeah, so basically if we would go out of bounds by adding the new speed on top of x, we just flip the speed around, like it bounces off. I mean, we did this right in our particle simulation, so something that's fairly common right now. So let's put the squirrely braces. I don't like it without squirrely braces. And otherwise the position is good. So then for y we do the same thing, and now we should see that it shoots up and then down. Yeah, I didn't expect that. So here if it goes below 0 it means that we lost. So let's make this an int. And if maybe have like a return 1 meaning that we lost or something. So we just don't do anything, and at the end we return 0 meaning that we are still playing. Okay, so now if we wait, I meant height actually, because I forgot that it's the other way around. So if it's less than 0 we just do that. So let's see, and then it stops because we lost. I mean, here let me just put parentheses around this because I don't trust defines. And yeah, so we have the update kind of working. Now we have to just check something about this one. So basically if we intersect with the paddle we have to do some stuff. So we have another else if condition. So else if new y is equal to game height, and we are basically inside of the paddle, so but this should be game height -1 because paddle is gonna be on that position and paddle is like this. It should switch to going back up, right? And if I just move out, it basically dies, right? So that's the main idea there. But I would like to make it a bit different. So I would also like to know what's the intersection point with the paddle. Can we do it in some other place? Here it looks a bit ugly. I guess let's have it as the first check. I mean, it's the same thing, but let's do something like so if, and here we're gonna have an else if. So if the game height less than that, and let's have an if statement inside. So basically if w pedal x is the left corner, right? So if the left corner is less than wx and wx is less than almost, right? Almost, right? So here I would say divide by 2, so we get this thing, and here I would say the x is going to be -1, so it goes to the left. Then we have an else if it's from this side, but I would say is greater than that, and here it should be equal, right? Am I right? Wait, no, it's right. So it's from paddle, and here it should also be less than, strict less than. And on the else case, we have to say if it hits straight on, it's gonna go W like that. So now I think this makes it go up and down. This makes it go like crazy. Okay, so I made a mistake basically. I guess here I should I should also have, well, let's just add the condition that wx is greater and like it's in this interval. So now it should be fine that if it falls down, it just stays down basically. Okay, so yeah, I mean the update I think is fine. It returns 1 when you lose. Okay, so that's when we should just reset everything. So let's say dx is 0 and dy is also 0. So if it falls down, then it just stops, right? So not sure how it gets here though, because game height. I guess yeah. I mean, it makes sense, but like if the new position would be this is like if the new position is outside, and this is if it's on top of the paddle. I mean, yeah, I guess it's fine. So when we draw it, we subtract pedal height. Oh, so then this should be pedal height, because we already have that. So yeah, and if we make pedal height for some reason 2, it should still work. Yeah. Let's say if it falls down, then it is what it is. Oh yeah, and we still can go outside with the paddle, so that's something we have to check. So here let's say int new paddle x is gonna be something like this, and if it's not out of bounds, then we can just move in that direction. Okay, yeah, the Canadian flag. Okay, so yeah, now we just have this, and basically if this thing is not equal to 0, then we just recreate the world from the beginning. Yeah, I mean, the only thing is that it's way too fast, to be honest, but that can be fixed by doing like something like 10 FPS, you know. And yeah, so yeah, I mean the respawn works, so that's pretty good. Would be interesting to add like breakout functionality though. That would be nice. So let's see if that would make sense, or at least how I would do it, because it would require us to have like an array, and when the ball collides with any of those things, we need to check. So instead of having a simple less than 0, we have to check here. Like, although yeah, in all cases we would have to check, unless it's this thing or this thing, because these two things are pretty much just the base case, right? Like if it goes below the, like it's the collision with the paddle and the collision with the game over stuff. So yeah, we would have to just check this place in a better way, and maybe this place. So yeah, let's just say we're gonna have define field rows is gonna be something like 2 or whatever, and here we might need an array, right, of status for each thing. Oh, well, I guess we can just reuse the logic of using uint like characters for this thing. Yeah, why not? Let's include std int.h, and yeah, we can just reuse the logic of having the game width is always 8. This is not gonna change, maybe only the height or something. And yeah, let's have, well, this stuff can actually be let's say uint 8t. Let's make them although the speed cannot really be, so it, I mean, what I can do here is use int 8t basically. Wait, isn't it? I thought that it's in standard int. Yeah, it is. Anyway, so let's have ints like this. Int 8t. Then we have the new pedal position. We just set it. We're gonna have to rework a bit that part. I think everything else is good. Okay, so let's have here eight cells, and this is gonna be just field rows. And yeah, basically we're gonna use the same logic as before. This 8 from here is gonna be for uint, and this is always gonna be 8, pretty much. Okay, so let's see now. We need to draw those things. So for the game width, I think let's make them green or something. I think that's the idea, although it didn't work because I haven't initialized them. So let's do here W cells. Okay, so I have to do something like 4 0b 1111 because it's filled, bruh. It's filled. Okay, so now we have to make them break. You have to make them break basically. So How are we gonna do that? We need a new X and new Y positions. Okay, new X and new Y positions. That check is available. Okay, so let me move this thing, although not sure what it does. Wait, let's see. Okay, anyway, so yeah, we are just gonna redo the logic basically. So if new y is less than, or at least less than equal to the field rows, that's when we are gonna have some checks pretty much. Then another case is to see like this thing, I guess. If we are equal to the pedal height, then if we are greater than pedal height, we just close the game, we lost. Okay. I mean, this could be the first if though, just to not make any problems. Like that's an if on its own. If we are greater or equal to game height, then it's over. Here I would also just do w x is gonna be equal to new y. Oh, I meant y. Just to make it not appear on the screen or something, I don't know. Like if you redo this function, it will just come here. So yeah. Okay, then what's left is to, well, this one is never gonna be called because of this. So we have to see here. This is not gonna be called. Okay. So if we are above the number of field rows, here we have to check if we collide with anything. So I would say something like collision is gonna be equal to new y and new x, right? So we have to do something like w, but y new y minus 1. I would just say new y, and 1 shifted to the left by new x. So that means we have a collision. Right. I mean, in this case, we can also just say if new y is less than 0, we just revert the direction. But yeah, basically if we were to go on top of a new cell that's set, because it's filled, I guess, we have to change the directions, but only for Y. So if this thing is set, right? If collision, we would have to unset it. And if you remember from the Arduino part, this is how you unset a bit. And yeah, otherwise we will just move forward as usual. So maybe this can come in the else statement, like here, and we don't really need this. Maybe something like this. So basically, if we go above the map, we switch. If we hit the pedal, we switch again. And on the else case, I forgot the curly brace. And on the else case, if we are below the number of field rows, we have to check if there is any collision. And otherwise, somewhere there. So yeah, if we are like that, okay, let's think more about it, because wow. So if we go out of bounds, here if we collide with the pedal, and here if we are in the mind zone, let's say. So we check for collision. If we have collision, we unset the cell and set the speed in the opposite direction. Yeah, that makes sense. Then I guess would also make sense to have the else here. So if it's not a collision, we just move. Okay. But yeah, I mean, it still doesn't work. Damn it. So because you can have collisions in any direction. So yeah, it's gonna be more. Okay, let's say we don't turn around then, and let's see what this does. So it just goes through all of them. Okay, that's then. I mean, okay, so it goes through some of them, but not all. Okay, so the strategy is you stay here and then you move one to the I mean, yeah, it's pretty scuffed. I mean, it's still too fast, to be honest. Yeah, whatever. So let's see how we can make it actually go in the right direction. So this can be an int 8t then. So this is the collision with that. This is the collision with the field rows. So it should come in this one. Okay, so I guess if you go out of bounds, let's make the frame rate even smaller, like 5 FPS, to see better what happens. So, and then it starts to go like that. which is okay. I mean, you have to click really fast to move. So, but when it's like this though, it goes too much in the X direction. So there's still something wrong with this. So if we have Y less than 0, let's not do X yet. Or I mean, yeah, sure, X should be done, like for the game width. But when do we actually move to the right and to the left? So if we go above the screen, I guess we shouldn't really move to the left or to the right. So we don't do anything. Okay. Then if we hit the pedal, again we update the speed, update the other stuff, but again we don't change the position. Then if we are in the case of field rows, I saw that we just unset this thing. What if we do the movement there? Like only on this case we check with the left and right of the ball. And we move these things somewhere here, something like that. Maybe it will look better. So it goes like that. And now if we move a bit to the... it's strange what happened there. Let me just go like this. So it comes, takes like a really small break. Okay, I mean it's really slow and it's hard to move around, but so it goes, but see, it still goes down even though it still went one step down even though it should not go one step down. So let's see, on the else case, maybe do something like this. Regardless if we are on the field rows, like it stays in place if it collides with the wall. And only then it continues. That's a bit ugly, but I mean it removes the sliding. Okay, let's try again to intercept this thing. So it should come here, right? Okay, yeah. Oh my god. This is really cursed. It's really... what? It's like always taking the same path. Oh my god, I have to make it a bit faster because let's make it like 30 FPS. this should so it always goes on the same path like that. Man, I mean, if you have high enough FPS, you won't even notice the. Bro, it's like literally always the same path. There's no way to change it. Yeah. So now I'm just thinking how to make the path a bit more changeable. I mean, if we make the pedal too large, then it doesn't make sense. Sure, we can make the pedal even smaller and maybe this will change stuff. No, not really. I was thinking that okay, let's see. I mean, I'm really don't understand. Okay, like the pedal is too. Bruh. Because it needs to be a bit decent to be able to play it on the Arduino, right? Okay, I mean, let's see. So we compute a new x and the new y. Um, I have no idea how to make it more random. Unless we just apply random speed whenever we collide with it, like that's the only option. So yeah, like let's try it maybe. Or maybe make it the other way around. Something really scuffed, like this. But this looks like it's makes it always the same. Like even if we are able to no, because it's like the map is symmetrical, so that's why it's not gonna. So yeah, maybe the only option is to make the speed random, right? So yeah, let's try that. Let's make the speed random. So we're gonna put here random, something like that. And this one has to be okay. So for random we need stdlib. Let's also include time because we are gonna need to s random time. Let's see now. but I mean it's still not gonna work, right? Because it's always gonna be in that direction. So let's maybe do something like modulo by 5 and subtract 2. So this will give us a range of speeds. And it's also that it's not yeah, it's a bit too difficult, I'll be honest. I mean, in case, okay, so the random, like the normal speed is fine, I think. But if we make it shoot out randomly from this thing, it should be better. So if we have a collision, right, if we have a collision, then we would have to set the y speed in the opposite direction. And this should be, I'm thinking it's only on the else case. Like if we didn't have a collision, we have to check this stuff. But I also feel like this thing should be done always. Let's see. Okay. Okay. So this just sets. Like I don't get it why it just froze. You know. One step below it. It should be if it's less than. Okay, if it's less than, and here it should see if it's a collision. Okay. So if it's a collision, then it's gonna do something to the speed. It's gonna make it in the opposite direction. My bad. Here I should say on the else case. Well, I mean, I would do the same thing on the else case. So, yeah, this should be just less than. Maybe collision should come outside equals to 0. And then we should have collision equal to this. Oh. Only when we come inside. Here we have to check this, and else if not collision we actually move it. So let's see. Okay, so that's gonna basically randomize a bit our game, because it's gonna jump around like that. Now it always hits that place. So now if we go again, but see, because we cannot exit the board, we cannot. Okay, so let's say it's greater than -1, and here I think we need to also add paddle width divided by 2. So Wait, we have to divide this one by 2. So now we can go out of bounds by 1, but not more than 1. So let's say you do that thing. Well, and now it just hmm. Okay, I mean, see, like you can go outside one step to try to make it. Yeah, like maybe the other thing we can do is if it touches the top layer, it gets a random direction or something. Like if it comes here, we have to randomize. Okay, so let's do include stdlib and include time.h. So it should be something like srand, and maybe here or here on collision we say w. Well, yeah, it makes sense to also have that. But I was just thinking that if you get a collision with the top layer to give you like some random X movement. So let's have here random, but that won't help, I guess. So yeah, let's try to do something like, okay, that's maybe that's better. Like what's important is, let's see if we can manage to try and beat the game once or something. Right, like that would be the achievement. Let's say. Funny. Okay. Yeah, but now see, it got a bit stuck, but it can get unstuck by doing something like that. Okay, didn't touch anything. If we come here, almost moved out of fear. Okay, so let's also actually let's do something like modulo 3 minus 1, and let's also randomize this place. So let's randomize that and that. I mean, even this could be randomized then, but this gives you a bit of well, stability when you hit the ball. Because you have the chance to to come straight down. It might be helpful. Yeah, I see come straight down and you move it back up, you get the last one or something like that. And yeah, now it goes random. But how can we, maybe if we move one step, Hmm. Like we kind of get stuck at some point, right? If we don't have like floating if we don't have like floating point movement. So maybe we also need random on this one to make stuff more randomized. And the pedal just gives you some random movement. Oh, why it broke? Ah, because I forgot about the Y direction. Okay, let's see. I mean, this would be really fun to have on the breadboard running. This, I mean, maybe if it's straight center, it gives you straight up, but if you get it like at an angle, it gives you random movement. But yeah, we have to think if it's like mathematically possible to have this as a one, as a win, basically. Because at some point, see, it's like just gonna go in the same place over and over again. So how can you then make things a bit better? My other idea was to have more speed sometimes. Like this could help, but it's, I don't know. It feels like bigger speed would be really hard to predict. And that's the only issue. And it's also that it gets collision with random stuff. Hmm. Yeah, I mean, uh, yeah, let's just keep it with speed one for now. And yeah, getting the input to work on like 5 FPS is really annoying. But okay, let's see. So oh my god, yeah, like that. Get a random movement. Okay. So will it go in the same place? Yeah, it goes in the same place. So now let's see when it's so yeah, when it's an even number of rows, that's when it gets stuck. So that would be the only thing that I haven't figured out yet is how to get it unstuck, basically. But let's do 5 rows. Yeah, I mean, maybe we should rename this project from Pong to Breakout. Okay, I'll just do normal FPS because it becomes annoying. So let's do 30 FPS, or I mean even 15 FPS is better. Oh, but it's so fast. It's so chaotic. Yeah, I mean it's not even like I got to win at the game. Like it's more about being able to get it on Arduino. Okay, I mean I see the benefit of having. So let's go back and let's keep this thing like it was because it's really gives you better control of the game if you do it like this. At least it feels like you have more control over it. So it's more less annoying, I want to say. Bruh. I'm curious to see if you can, well, yeah, like the chippy chapa, if you know what I mean. Oh, that's really cool that it can, yeah, and it still behaves like the usual breakout, like if you go in the middle of the square, it becomes like, starts to destroy everything. That's, okay, that's good. I mean, the only, but I think that doesn't help. Yeah, I mean, at some point you get stuck, but I mean, it's maybe more about how many uh, squares you can break before you get stuck. So let's call it a feature, and I guess that's the feature then. Yeah, we'll have these randoms here, but yeah, we'll see how we can do that from Arduino. I mean, I saw that it works, so it shouldn't really be a problem, but yeah, so this part right here is what we're gonna need to copy paste, and I mean that's pretty much everything. So uint 8t, let's just clean up a bit the code, but we've got some really basic gameplay for the Arduino, right? So this is just a demo in Raylib, just what we are expecting to get. So yeah, I guess this will be like a small intermission. I mean, pretty large one, but yeah, we'll see what I can do on the Arduino then. So yeah, I see you there. Okay, so now let's, I guess, continue with the Arduino stuff. So let's do a main.c file. let's go. Let's switch between Tetris bits, right? Because we need the make file. So yeah, here I'm gonna have a make file, and I guess the make file should be really simple. So it's gonna be, I mean, let's skip a bin directory and stuff. So basically we don't need these headers, I think. So the directory is gonna be current directory, something like that. Okay, it's gonna be the current directory, and then here we take all the sources, which is just main. I mean, it's a bit scuffed, but I think it should do the job. Instead of Tetris, let's say Pong. Pong, I mean, if I just rename Tetris to Pong, probably it's gonna be better. Okay, so let's cd back and go into Arduino. Make, oh, I think it's just make. Yeah, it should be just make, but I mean, we don't have any code. So let's go back to Tetris bits and take, well, we can just, copy paste. So Tetris bits src at mega. We need both the lc.h and main c. So yeah, basically this lc I did it a while back. Oh, and we also can use something like compile flags. I mean, I did it in the same video with the Tetris. So compile flags, let's move it into, sure, there. So yeah, what I want to say is I made this one to make it easier to control this stuff, because the one that is on GitHub already is made for like the Arduino IDE, so we cannot use it. So we don't have to do Tetris implementation, and we don't have to use this stuff. So let's just copy paste. As I said, we have to copy paste the code from Pong. So we need just this stuff. So let's paste it somewhere like here. Maybe we can put it like here, just to make it obvious that this is a Pong game. Okay, so this and Pong game, whatever. And we have to define, as usual, the world in as a global variable. I mean, we also did it here, so make it equal to 0. We use this stuff as usual, and then what we have to do is to set up the LED matrix. Okay, we set up that thing. Then we have to do world init. We initialize the world, and I think, yeah, this should do some fillings. Okay, we don't really have that. Do we have? We don't even have move. We just have direction. So for the input, we just use input directly, I guess. So this should be update, and update takes in the input and the world. We don't really need that because we don't have it. Then we have to draw the thing. Okay, so we have to redraw the stuff. Oh, and yeah, this one is a good check. So basically, if we die, we just restart the world. Also clear the display. I think that's all we have to do there. So that's that. And here we have to set the rows. So board height. Board height should be the same as game height. So let's set here board height. Okay. So I guess drawing is a bit different. So let's see. We'll start from, let's say, okay, so I mean, let's see how we can do that. So first of all, let's try to just draw the paddle. So the paddle is gonna be at 0. So it's gonna be, I guess I want to draw it there, probably, just to make it clear on the screen. So let's maybe have a draw function, and it takes something like that as arguments. So we go here and do void draw, and it's gonna take the world and that. Yeah, I mean, now it would be nice to have the controller be able to just show single LED, but we don't have that, obviously. So it will make sense to just take do something like so. Let's remove that. So here from start to end, but yeah, you should also, okay, so let's have maybe a for loop for all the board height. It's from top to bottom, and we just create an array like status. So we're gonna have uint 8 is gonna be status, and this is gonna be the status of each LED, pretty much. So for index 0, it's pretty easy. Index 0 is gonna be the position of the paddle, right? So we take, let's see how I define the position of the paddle. So position of the paddle is a uint 8. Okay, so let's say, I mean, int 8 tx, paddle x, this is the position of the paddle, and int y is gonna be, I would say 0, right? So it's gonna be 0. So then which we'd have to say status of 0 is gonna be something like 1, and we have to shift it not really by x, but more like 8 minus x. 8 minus x. So this this enables the first position, but we also need to do it a couple of times. So let's make this one 0 first, then have a for loop int 8t, and this is going to be like xi, right? Xi is going to be less than paddle width, right? And we have to set this this thing. So let's try to make build. It doesn't really work. Didn't it work on this one? I thought, yeah, here it worked. What? Okay, let me just make clean, make build. Okay. I'm not sure. I mean, let's simplify the big file. Let's still keep the so this should be main, and maybe also lc.h. So let's call this one main.o. We don't really need this. Let's see. Okay, I mean that works. That's fine. This one should be main elf. Something like this. Main.o. Main.o and main.elf. And then let's say main hex is gonna be main elf. It's missing something, I think. Oh no, it's fine. I mean, here we should have main, and this one also main. I mean, let's also do minus g or something. Make clean, make build. Oh, it should be I guess something like this first argument. Okay, so now it was fine. Anyway, make sudo make copy, sudo make copy. So I think we should see just, I thought we were gonna see the single line, but we don't. Then I'm really, so here we should say set row and we give it the row. I forgot about actually setting the rows. We have to initialize this entire array with zeros because otherwise it's gonna be random. So we don't have that, and let's try again. So yeah, now it actually sets this thing, and if we take a look, wait, where is it? CD GUI. It's in the same position basically, although it's upside down. So then how about I'm gonna put it, but I mean then this is the 0th column, so it was fine. I mean let's keep it in the other. Oh no, actually yeah, it's gonna look fine. Yeah, I'll keep it like this. Okay. I don't know what I was thinking. So now let's set for uint 80 for the number of field rows. Okay, what we actually have to do is okay, so field rows is pretty much the ones at the top. So we have to do something like board height minus field rows up until board height. And then here we are gonna set we kinda have to set, yeah, we need another for loop for j from 0 to game width, and we have to do something like status I is gonna be world cells. This one is still like this, so it's gonna be cells and one shifted the right by j amount, so that's fine. Wait 1 second. Here, was it like position? Man, this bit shifting is so hard though, because for the pedal width I was not sure if it's right. So basically there we have one shifted to the left, and we use x plus something, and x is the position. So initially the position should be something like 4, I think, if we look at how we initialize the game. So we initialize the game. Well, I think this thing should move. I mean, it loses instantly, so you don't really have time to see what happens. um, yeah, so when we initialize the game, we set the pedal to be game width minus pedal width, so it's gonna be 3. I mean, it looks alright on the screen, so maybe it's fine. Although it's like x will be 3 and then xi will be 0, 1 and 2. So it's gonna be shifted 5, 4 and 3. 1, 2, 3. It still doesn't make any sense, but because yeah, initially pedal x, as I said, is gonna be game width divided by 2, which is 4. 8 divided by 4. And also minus pedal width, which is 3 divided by 2 is 1. So it's 4 minus 1 is 3. So this is gonna be 3. And here it's 3 plus 0, which is 3, 4 and 5. So it should be bits 3, 4 and 5. Also it's from okay, so it's from left to right, which is even better then. Although yeah, I have no idea why. Pretty interesting. I mean, perfect, right? It's not important. If it's mirrored, then it's fine. Anyway, so here we take the cell, we shift to the left by j amount, and yeah, if it's 1 or well, I mean, isn't it just cells? What am I doing? It's just cells. I mean, what is ChatGPT doing? It's just cells. W cells I, right? It should be just cells. Ah, that's filled rows. Okay, then I guess it makes sense to go from 0 to filled rows. And here let's do board height minus filled rows plus I. So this should also display the filled rows. Let's see what happens. It doesn't. So board height is 16, filled rows is 5. Oh, made a mistake there, so it should be like this. Although it's the same thing. So why wouldn't it work? So I said this thing is a new int 8. And let's do I, and it is what it is. It will overwrite it, but at least we are gonna see. Yeah, that looks good. I mean, funny that. Anyway, so then what's wrong with doing board height minus filled rows? So this is gonna be what? 16 minus 5 is 11. I think it's minus 1 plus I. Should be maybe like this. Still no. Ah, Yeah, I mean, I have to do it in another way. So here we have to say something like I divided by 10 or by 8 and I modulo 8 because we want to set the second controller. Okay, and it was fine without the -1. Perfect. But they are flipped. So then, wait, how are they flipped though? So this means the first one is at the top. So then let's do minus I -1. This should make it work, right? So, yeah, but we don't see the ball. So now let's also add the ball in the status. So after we do everything, we have to get basically, yeah, I wanted to try to make it a bit longer, but it's just we take the ball, the Y of the ball, that's the row where we want to place it, and the X of the ball is the column, so we have to do this thing. So that just makes it oh no, something's stupid with the ball. It's the other way around. It moves in reverse. No. Oh no. It moves in reverse. So let's do something like board height minus this thing and maybe -1. No idea why it moves in reverse, but oh no, it fell. Oh my god, it actually works. But like the input is really bad, I have no idea. Maybe it's this button which is a bit scuffed. Let me try to use the other. I have 3 buttons, like especially because of this. Maybe it's like that button is a bit scuffed and doesn't really. Oh no. Stay in its position, and sometimes it but it's maybe it's the breadboard, because sometimes it looks like it floats a bit, so maybe that's the issue. Let me just try to, I don't know, like move it from there in another place. Like I think I should just pull this thing out. Like see, it starts to move, so maybe just move the button somewhere where it stays fixed. So like, I don't know, maybe up here. It looks fine. You know what, I'll just pull this thing out because I'm not confident in my skills of moving stuff around. Say like this thing just flew. So put it there, and now let's just put in the resistor like this, and I'll just pull this other thing out. Okay, something like this. Let me just, move the first wire there, and just to keep the control scheme the same. And now it looks a bit like it doesn't move anymore, so hopefully, yeah, now see it's no longer, the input is much better. I was too quick on that one. Sometimes it's bad, but I think it's just because the button comes out or something. Oh no. Yeah, I think it's like some of the wires don't connect well or something. Sure, it cannot be my bad code. Surely it is something to do with. But yeah, we actually managed to get some form of breakout running on the breadboard in Arduino. But yeah, see, like, I think the button, yeah, sometimes the button comes out. That's why it's going like that. But it's just a prototype, so it doesn't really matter that it's really bad. I would like to see someone winning on this game because it's really, really hard. But yeah, we actually managed to get. Well, I said Pong, but it's more like a breakout. And yeah, I think this is a pretty nice result. Yeah, what were the chances of both extra buttons being lame? Let me just try hard a bit and use both hands in the controls. So yeah. It's annoying that the controls are reversed, so I'm using my left hand to go to the right. So what's nice about that is you just have to switch the wires around. You don't have to change the code. So now we can just continue. So yeah, stuff works. If you keep your hands on the buttons, they don't really come out. But if you move your hands and they move, oh my god, I hit a sweet spot there. But yeah, sometimes, like if you, oh, it, yeah, and also did that random, oh my god, I failed. Also did that random changing, so it doesn't always get stuck. Yeah, well, again, there is some cable. Yeah, so I guess we actually managed to get this thing running, which is again pretty nice. So yeah, we first we figured out how to actually use interrupts. Then I did a small intermission of, well, I mean, put the cables together and stuff, but that's what we also did in the Tetris project. So we already knew how to do that, pretty simple. Then was the intermission, let's call it, of doing the Raylib implementation, just to see how I can envision the Tetris game, how it should look like. And yeah, then we actually just copy pasted the code and it worked almost first try on the board, so that's good. I mean, only the rendering was not first try, but the logic was pretty much first try. So yeah, I mean, I guess that's a pretty nice result. So let me see. Probably just have to add just this stuff to Git, and yeah, I'll put the repo in the description. So I'll see you guys on the next one.